Hey everyone, in this video I'll show you how to verify that two functions are inverses of each other. To do that, we'll compose the functions. First, we'll look at f of g of x. So if you need information on how to compose functions, I will put a link in the description box, so check that out. So to compose f of g of x, we'll copy the function f of x. Every time we get to an x, we'll plug in the entire function of g of x. 3 minus 4. Now, I've got an x here. What I'll do first is put parentheses in place of the x, and that reminds me to plug in the g of x function. Now, I notice that this 4 will cancel out with this 4. I can simplify, so that gives me 3 minus, this is still a minus sign, 3 minus the quantity 3 minus x. Now I'll distribute this negative sign, so it gives me 3 minus 3 plus x. These guys cancel out, and my final answer is x. So that's looking like it's going to be an inverse, but we need to check the other direction too. So we test out g of f of x, we compose those. So similarly, I'll copy the function. When I get to an x, I like to just put parentheses. And then I'll copy in the f of x function. So 3 minus 4x. Then I'll simplify to remove the parentheses. So that's 3 minus 3, distribute that negative sign, so that'll be plus 4x over 4. These 3's cancel out, leaving me with 4x over 4. The 4's cancel out, and I get x. So in both cases, when I compose the functions both ways, I get x. And when that happens, you have verified that the functions are, in fact, inverses. What do the graphs of these functions look like? Because graphs of inverses have a special characteristic. Well, first I'll set each one up in y equals mx plus b format, because they're both linear functions. So f of x equals 3 minus 4x, and I can rewrite that as negative 4x plus 3. So to graph that, I know the y-intercept is 3, the slope is negative 4, so I go over 1, down 4, etc. So this would be the graph of f of x, so f. And I will graph g of x in red. And so g of x equals 3 minus x over 4. We could rewrite that as 3/4 minus x over 4. And I'll rewrite it again as negative 1/4 x plus 3 over 4. So that graph will, let's see, my y-intercept is positive 3/4, so that's about here. A couple other points on the graph. Let's see. If I let x equal 3, that will give me 0. And if I let x equal negative 1, that will give me 3 minus negative 1 is 4. 4 over 4 is 1. So negative 1 for x will give me positive 1 for y. So there's my line for g of x. So these functions are inverses, and the special characteristic that graphs of inverses have is they will be symmetrical across the line y equals x. So we'll graph that and take a look at that. So they've got symmetry across the line y equals x. And that will be true for any functions that are inverses of each other.